Hello, grade 9s, and you know what I think we need to do? Of course, we need to make it maths. Okay, cool. So let's look at doing this. Now, what we're going to do is just run through a few examples. So they're here, you've got them for reference, and then you're going to spend the next couple of lessons just going through and practicing yourself. So let's go through them nice and gently. So solving linear equations. Solve x, 4x minus 3 equals 2x plus 7. I kind of have one golden rule, because I think you've solved the equations by now. So our golden rule is what you do on one side of the equation, you do on the other. So let's just keep that in mind. Now, we've got 4x minus 3 equals 2x plus 7. Now, maybe just as a guess, because, not right or wrong, but I want to do something, and do you think I want my x's to be on the left-hand side? Or do you think that I want our x's to be on the right-hand side? Which way do you think I'm going to do, and why? Okay, so obviously you get no idea which way I'm going to go, but your y is going to be interesting to read. Now, I'm going to go for this option, x is on the left-hand side. And my reason for that is I've got 4x here and I've got 2x here. So if I subtract 2x from each side of my equation, I know that I'm going to have 2x, because 4x minus 2x is 2x, and 2x minus 2x, no x's. So therefore, what I want to do is, I don't want this pesky minus 3 over here. So what do I need to do on each side of my equation so that I've just got 2x here, I don't have negative 3? We're going to do kind of that opposite. So we're subtracting 3, so let's add 3 to both sides. So minus 7 plus 3 is minus 4. Okay, so our final step, of course, is that we want x, not 2x. So what do we need to do to each side of our equation? Well, we need to divide by 2, because we're dividing by the coefficient of x. So 2x over 2 is x, because now we've done a few of these, like the 2's kind of cancel out. And minus 4 over 2. What is minus 4 over 2? I think it's minus 150. No, it's just minus 2, right? Okay, so there's our first example. Let's just run through a few and see if anything interesting pops up. 7x plus 2 equals 4x minus 13. My question to you is simply, what's the answer? What's x equal to? Okay, well, let's see if what you wrote is what we get now. And maybe they're going to be different. Maybe I'll make a mistake. No, you're not there to go, come on, you made a mistake. Okay, so let's go for it. So I want to subtract 4x from each side of my equation so that those are gone. So I'm going to end up with 3x. And for others, well, I don't want this this plus 2, so I'm going to subtract 2. What I do on one side, I'm going to do on the other. So minus 15. I'm going to divide both sides by 3, and what do I get? I get negative 5. I wonder if that's what you got or not. Well, we'll see. Doesn't really matter. I don't know. Maybe I made a mistake there. Maybe not. Let's move on. Next example. Solve x, 5x minus 3 equals 2x minus 1. And the question is, what's your value of x? Okay. So again, now notice that I'm purposely kind of going through these. I'm not showing all of these steps. I'm not going 5x minus 3 equals 2x minus 1. And what we need to do is we need to subtract 2x from each side. So I'm writing the minus 2x really nicely. And therefore that minus that is 3x minus 3 equals 2x minus 1. And then I'm going to rewrite the whole thing. 3x minus 3 equals minus 1. I need to plus. No, I was plussing the wrong thing. You see, I'm losing my mind already. Plus 3 plus 3. So 3x equals equals 2. And then I'm going to divide 3. Okay, so there's a reason for that. We know that we're doing all of these things. I'm picking out the bits that are important to show and how we can show it a whole lot more efficiently. And we're not taking shortcuts. We are just writing out this is going to take you 5 minutes per question, and you're more likely to make a mistake and still know what you're doing, but make a mistake just because you're going to chop on a banana peel than if you do it in that nice, efficient way. Okay, and I'm going to fall asleep. Okay, so solve for x, and this one, to solve this one, what's the first thing that you're going to do here, though? So You might want to add your 2 to both sides the same, but I think that what's probably best to do is distribute this in here. So we got 5x plus 5 minus 2. And on the right-hand side, we're going to do a similar thing with this 3 and go 3x plus 3. Definitely a useful step, not a yawn step. Okay, then we've got plus 5 minus 2. Now, you might have gone, oh, well, 5 minus 2, you could have seen that that was 3. I wouldn't do that. It's just so easy to make a mistake, and then you forget and you go, oh, well, 5 times 1 is 1 and 1 minus 2 is minus 1. It's just too easy to make a mistake. So it doesn't take much to just do that. You're writing things quickly. 5x plus 3 equals, and on this side we got 3x plus 3. Now, the plus 3's, you've got 3 on each side. So if you subtract 3 from each side, I'm going to do it this way around and go, well, 5x equals 3x. Because, you just subtracted 3 from each side. But maybe you didn't. So let's leave a little working space because you might have done it differently. So we'll do that above my head and see. What do you think? Maybe you're like, don't. And well, I'm going to do it anyway. You know that. So at this stage, we can't just go, oh, divided by 5 or divided by 3. We still need to have our x's on one side. So I'm going to subtract 3x from each side. So on the left-hand side, I've got 2x. Now, what's 3x minus 3x? Well, the way I figure it, it's 0. And now instead of going divide by 2, divided by 2, I'm going to ask the question in a slightly different way. 2 times x is 0. So in other words, 2 times what would give you 0? Well, it must be 0, right? Because 2 times 0 must be 0. Like, what else could that be? So instead of going divide by 2, divided by 2, just pause and think through that step. Well, 2 times what gives you 0? Well, that what must be 0. Okay, maybe just because you might have done it differently, let's find a nice color here. Over here, you subtracted 3x from each side, so you end up with your 2x, and you subtracted 3 from each side. Well, you would have got your 2x equals 0. So maybe if you didn't do my step here, you would have skipped that and got straight to there. So maybe that would have been a great option. Okay, so our last 3 examples. And I was going to do this in let's do this. No, let's do it in this one. I feel like I've still got the momentum. So let's keep going with this one. So we've got 3 examples. We could end up with one solution. So this question here, x equals something. What does x equal for this question? Well, I'm going to do it like this. Remember, we want to subtract 3x from each side because those are going to give you 0. So you've got 2x. And we want to add 2 to each side of our equation. So that's 0 equals 8. And I've already written it in red. And just maybe now is a chance if you want to. I generally try and not use reds and greens because they're the colors most likely to be mixed up. I can clearly see the reds and the greens differently, but not everyone can. So maybe pop down if the reds and the greens look similar to you, or if the reds and the greens look completely different. Okay, well, that's interesting, and maybe now is a nice time because we could just ask privately. But if you notice, I try and avoid using those together. So let's go for an orange. Maybe the orange looks similar. I know oranges and blue. No, maybe. Okay, so now we're going to divide by 2, divide by 2. But again, we could have asked ourselves the question, 2 times what gives you 8? Well, that what must be 4. Or we divided both sides by 2. Either way, one answer, x equals 4. What we haven't done so far, but let's do it. Let's check if it works. So 5x minus 2 equals 3x plus 6. If we substitute 4 in, what is the left-hand side of our equation if we substitute x equals 4 in? Well, 5 times 4 minus 2, 20 minus 2 is 18. Okay, let's look at our right-hand side. So in our right-hand side, if we substitute x equals 4, what do we get? Well, 3 times 4 plus 6, 3 times 4 is 12, 12 plus 6 is 18. So where's it? Over there. 18 equals 18. Yes, so that's a valid solution. Okay, so let's have a look at some no solutions answer. In this case, multiply out the left-hand side, so distribute this 2, and let me know what you get. Okay, well, I get 2x minus 6, and on the right-hand side, I get 2x plus 4. Something doesn't look so great yet. 2x minus 6 is 2x plus 4. So some sort of number, when you subtract 6 from it, is going to be the same number when you add 4 to it. That doesn't quite seem to make sense. Let's just do this in 2 steps. That's plus 6 to both sides of our equation. So we've just got 2x on the left-hand side. So 2x equals 2x plus 10. So some number is the same as itself plus 10. So like 2 is the same number as 12. Or like 14 is the same as the number 20. Like, is this 0 is the same as 0 plus 10, 10? No, none of these are working. So let's see what's going on. What happens if we subtracted 2x from each side? Because we don't want that 2x over there, right? We just want the 10 on the right-hand side. Equals 10. 2x minus 2x. What's 2x minus 2x? That's 0. No, wait. Is 0 equal to 10? No. Is 0 ever going to equal 10? Like, it doesn't matter what x is. Put x as 100. Put x as minus 3. Put x as 7,421708. No. 0 is not going to equal 10. So because that's not going to equal, we're going to say there's no solution. In other words, it doesn't matter what value you make x. This is never going to be true. This equation is never true for any real value of x. It's never going to work. Okay, so our last kind of option that we get when we solve. And the nice thing is, having sat through this ed puzzle and engaging and loving every second of it, right, is that you get to just practice for this lesson and the next one. So for this one, multiply out, write it down, multiply out the left-hand side, try and solve it, see where you get to, and write down your observation. So solve it and just write down what you see and describe what you're noticing and exploring and finding out. Okay, so I'll say this, but I'm fascinated now because that's going to be some interesting reading. So I'm going to distribute this into the bracket. So 3x minus 2 times x is minus 2x. Minus 2 times minus 3 is plus 6 equals x plus 6. Okay, 3x minus 2x is x. X plus 6 equals x plus 6. Well, they look the same, don't they? Like, what values of x could this work for? Let's try like a number like 1. Is 1 plus 6 the same as 1 plus 6? Yeah. What about 10 if x is 10? Remember, x is the same value. If x is 10, is 10 plus 6 equal to 10 plus 6? Okay, and maybe you wrote this in your description earlier. And if we wanted to kind of try and keep solving this, because we didn't see it over here. I mean, what we can see here already is that this is always going to be true, right? Always true. In other words, x is any number, any real number, because we're dealing with real numbers. So this is always going to be true, because x plus 6 is x plus 6. They're the same thing. But maybe you kept on solving your equation, because this often happens, is that, and you went, okay, well, I'm going to subtract 6 from each side of my equation. So I've got x equals x. Or I'm going to subtract x from each side of my equation. I've got 0 equals 0. Or you subtracted x from your equation and you had like 6 equals 6. The point is, what's on the left-hand side, the right-hand side, you've got something that says the left-hand side equals the right-hand side. Whoa. What's going on here? The right-hand side. Okay. So the left-hand side equals the right-hand side. In other words, it doesn't matter what x is. This is always going to be true. 0 is always equal to 0. X is always equal to x. 6 is always equal to 6. X plus 6 is always x plus 6. 3x minus 2 into x minus 3 is always x plus 6. So for this, however you write it, some sort of x is any real number. It's always true. True for all values of x. However you want to write that. Doesn't really matter how I would choose this one here because that kind of gets us towards something. But x is any real number. It's true for any x. So that's kind of our third way. So it's not always just one solution. You could have true for all x, you might have no solutions, or you could have one solution. So that's what our things for linear equations, which you're doing this year. Next year you might have just 2 solutions, or 3, or just 7. But for now, 1, none, or all. Okay, so that's that. You've got an exercise to do. Exercise 17 is your friend on page 45 and 46. So enjoy those, pop in for questions, and of course, you know what you need to do. You need to make it maths.